Thank you. As David said, my main line of work is working on exotic species, but I'm going to talk a little bit off topic today on another interest of mine having to do with the history of San Francisco Bay and the management of the bay. To address the question of how information about the past can or should or does inform our restoration planning and activities. During my, my professional lifetime, the environmental movement has undergone a dramatic shift in parts of its activities. It's gone from being essentially entirely reactive, trying to preserve what we have in the environment, trying to prevent additional damage to the environment, to including an active or proactive component that we call restoration, which typically is aided towards something that has to do with recovering some of what things were like in the past or repairing damage that we've done to the environment. The exact target that we're aiming at in the past changes from project to project, not in a particular year. Sometimes it's not, to recreate something that's exactly in the past, but to use the past as a guide for how we want to manage things in the future. But it's always about recovering something that we've lost, about repairing some damage that we've done, and is proactive in that sense. In San Francisco Bay, the first and the largest effort in this regard has been, as Robin discussed in many projects, the restoration of tidal wetlands, and tidal salt marsh, and tidal brackish marsh in this picture. This map in the speckled lines shows, you've seen this in other versions before, it shows the marsh that existed in San Francisco Bay at the time of European contact, or at least prior to 1850 when we first started to map it. And the black spots that are up on this map show what's left, the little dots up there. And so instead of simply trying to preserve those little dots and trying to keep them from shrinking, the environmental community and the regulatory community in San Francisco Bay embarked on an effort to try and increase the area of black, and increase the area of actual marsh there. And the numbers on this, like you put the wrong arrow here, the numbers before 1850, we think there were almost 200,000 acres of salt marsh in San Francisco Bay. We're not exactly sure when the low point is, but an estimate in 1979 was about 31,000. 2000, the Bays Project estimated about 40,000 and set a target of 100,000, restoring about half of the acreage of salt marshes that existed in San Francisco Bay. Since 2000, as Robin showed you in the Napa River area and also in other parts of the bay, projects have been completed, other projects are in progress, and our expectation is that over so we have something more than 40,000 at this point, and it certainly looks like over the coming years and coming decades, we're going to see thousands, if not tens of thousands, of additional salt marsh acreage being created in San Francisco Bay. It's a really astonishing achievement in many, many ways. That didn't come without hard work and some wrong turns. We began working on figuring out how to do salt marsh restoration here. Some people did in the 1960s with some experiments. Projects really got going in the 1970s. These projects were essentially mitigation for shoreline development. You develop some property here, you have to do something to improve marsh or create new marsh over there. Initially, many of the projects involved planting, as shown here. And so plants were transplanted from one marsh to another. Some plants were raised from seed, planted, many different planting techniques to try and keep them from eroding out. Big focus of salt marsh restoration in those days. In the 1980s, there were a couple of rather scathing reports about the work that had been done on salt marsh restoration, arguing that, in fact, although there had been many projects and projects had been completed and they'd been declared successful, that in fact there had been relatively little gain, or as far as we knew, little gain in terms of new marsh or improvements to marsh. That a project would involve going out, planting a salt marsh with plants, and then check it was completed and done, and if the plants died a year or two later, it was still checked off as a successful project. There was not, in many of these projects, any kind of ongoing monitoring or long-term management of the site. The goals were often not clear. Is it just to put a plant in the ground, or is it to actually have a functioning, self-sustaining salt marsh at the end? And there wasn't a lot of transparency. There wasn't a lot of record keeping. It was hard to know what was going on. And it's really hard to know what had happened to most of these projects. And so a suite of criticisms of the process, which were hard issues, but were dealt with. Marsh restoration got on much better footing. Long-term monitoring is built into the projects. And we're clearer about what the goals are. We're not simply putting water on the land that didn't have water before and calling it a wetland. We're not simply sticking some plants in the ground. We have to have a functioning, sustainable marsh in the end. We've also learned much more about how to do that. It turns out that the planting that we were doing was largely a waste of time. If we got the conditions in the marsh right, the land at the right elevation, the sediment of the right quality, the water channels of the appropriate size so that water can move on and out, so good circulation through it, then any planting, whether we had planted that site or not, vegetation would come in and colonize it in a relatively short time. And if we didn't get the conditions right, any planting we did would die off. And so as we do marsh work today, planting is either a minor part of it or probably a non-existent part of it at this point. And what we do is we work on getting the conditions right. We develop a better understanding, and Robin talked about many of these things. And the tools for getting the conditions right, once you've figured out what you want to do, it's basically about moving dirt around. It's bulldozer work, it's backhoe work, and so the typical salt marsh project now looks more like this. Putting the right tools to the job to move water into an area, reach a levee and move water into an area that hadn't had water before, which has been shaped by earth moving equipment into the right kind of configuration for a marsh to grow there. That planting was all that planting work that we did, it was actually worse than being useless, as it turns out. There are a couple of ways, although the acreage achievements of salt marsh restoration are tremendous, there are some ways in which some perspectives from which it hasn't been quite successful. And one of them is that in that planting operation, in those planting operations, one of the things that was done was at one point, some restorers, who knows what was going through their heads, some restorers planted an East Coast cordgrass, an invasive East Coast cordgrass in the San Francisco Bay Marsh as part of a marsh restoration project. That cordgrass spread. We currently have in the Bay a multi-million-dollar, multi-year project to try and get rid of this cordgrass, which grows very different from any of the native marsh, completely changes the structure of the marsh, changes the faunal relations in the marsh, changes the marsh in many, many ways from what native West Coast marshes look like. And it is unclear whether that project is ultimately going to be successful. It's not entirely clear at what point it's going to be ended, at what the end point is that they're aiming for, and even if they achieve that end point, the remaining genome of this exotic marsh plant that will be left in the bay won't recolonize it again. And so a lot of uncertainty and potential real harm to marsh restoration projects because it's something that we shouldn't even been doing, planting, didn't even need to be doing, putting plants up there. So I had to say something about exotic species. Back to the main topic. So what does ecohistorical knowledge, our historical ecology studies, what does this we know about the past of these environments? How does that inform, and I'm looking on the big scale here, how does that inform our restoration efforts, and in particular the salt marsh restoration efforts in the bay? First of all, and this may seem so basic it doesn't need mentioning, but bear with me. First of all, that knowledge tells us that marshes were more abundant in the past than they are now. Around 200,000 acres in the past, around 40, we moved up to 50,000 acres maybe now. We still have a ways to go before we have as much salt marsh as we did in the past. That gives us some inspiration and rationale for going forward. But even more than that, for some types of restoration, what that does is it tells us that it's possible. If the marsh had a lot of salt, if the bay had a lot of salt marsh in the past, we have more confidence that we can actually create salt marsh in it again. If it never had much salt marsh, there would be some reason to doubt that. In the case of salt marsh restoration, we now know the techniques reasonably well enough. We've been working on it since 1960. We now know it. Can you hear me back there? Or? No. I thought I turned it on. Is it not? It's turned around. Is that better? Okay. Okay. I'm happier if you can hear me too. So we know a lot about salt marsh restoration, so we might have pretty fair confidence that we could restore and create some new tidal marsh, even if we went beyond the numbers in the past. But for types of restorations where we don't have 40 years of study behind us, knowing that there was a lot of this particular habitat or that species in the past is an important aspect of our assessment of what we can do in the future. Our knowledge also tells us something about why we lost it and things that have happened with salt marsh in the time since those areas since we lost it that might be issues we have to deal with. We lost salt marsh in the bay essentially because we closed it off from the tides. And so the first thing we have to do is open them back up to the tides. And we know that that's one of the steps we have to do. In many cases, the level of the sediment has also lowered relative to the water level over time. Subsidence is one of the reasons, compaction also in some areas. And so in many cases, we have to build the surface back up and we have to open them up into the tides. There may be other things we need to do, but those are fundamental. Without doing those, getting the land to the right elevation, the tides back in, we will not have more salt marshes. And we know that because we understand what happened in the past. And then we know a lot of details of what went on, as Robin described. Sometimes we can recreate the actual details that existed in the places where they did. More often, we understand what the mix of features are in, say, a salt marsh. How much salt pan, how much pond area, well, how much first, second, and third order stream. And we can try and create something that has that kind of mix in the marshes that we restore. So I provide some guidance in the details of what we do. With that as background, let's take a look at a novel, relatively new restoration effort in San Francisco Bay, the effort to restore the native oyster, the common name Olympia oyster, scientific name Ostrea lorida, to restore that oyster to San Francisco Bay. And the question I want to explore is what does our knowledge of the ecological history of this organism in the bay tell us about our opportunities and potential success of restoration? These are a set of quotes from various researchers describing the initial condition of prodigious quantities of oysters in the bay, super abundant. Oysters littered the bay, which is our understanding, general understanding of what the condition was at the time of European contact and in the early days of colonization of the Bay Area. And in the middle quote, also the statement that there was a rapid decline of these resources soon after white men arrived. So far, so good. What caused this decline? Well, there are different sources have provided different answers. These newspaper and newsletter quotes happen to be the most on-point ones to quote. The Sacramento Bee says it was overharvesting that did it. Save the Bay's newsletter says it's overharvesting and pollution, and the San Jose Mercury News says it's overharvesting, pollution, and miner's silt, silt sediment coming down from hydraulic mining in the Sierra Nevada. And generally in the literature and in presentations, you hear that these are the causes, one or the other, or a mix of these causes in some combination, which decimated the populations of native oysters in the bay. And then there's a third element, a more recent element in all of this. Statements here from a couple of researchers about how after having been missing from the bay for a long time, the native oyster started to reappear in the late 1990s and was discovered in different places in San Francisco Bay. And so when you summarize this history of the oyster in San Francisco Bay, abundant initially, declined due to overharvesting, pollution, or hydraulic mining sediment, or some combination of those, gone from the bay, or virtually gone from the bay, not quite agreement on that, for a long period, and then reappearance and rediscovery. And so what this would tell us about restoration opportunities, one, it was first abundant, so we have that first test that there's a potential here to, again, have abundant oysters in the bay. Second, we have some ideas about what did them in, but we're not entirely sure about what they are, so that's not quite as clear as it is with salt marsh restoration. But they seem to be coming back, and we know that we're not over-harvesting anymore, so that we're not harvesting at all, and we can prevent over-harvesting, presumably, if the oyster comes back by regulation. And so to the extent that that was the problem, we fixed that one. And we're no longer doing hydraulic mining in the Sierra Nevada, and in fact, the sediment loads into the bay have declined from what they were for a long time in the bay. They were elevated levels of sediment coming in because of erosion upstream and so on, and it's leveled back down. So that problem is solved. And maybe they're coming back now because the third problem, also a contributor, or maybe a main factor, pollution. Maybe it's gotten good enough in the bay that they're coming back. In any event, there is some evidence then they're coming back, giving us some hope that, maybe hope that we can help that process along, or alternately, maybe we don't need to do anything and it would come back anyway. So if we do have a restoration project, we're certain to succeed. Because even if we do nothing, they're coming back. Good time to launch a project then. So all this is fine, except that that latter part of it didn't really seem to fit with my experience working in the Bay. I started working in the Bay in the early 1990s. And my impression and recollection is that I used to find the oysters around San Francisco Bay. They were never very common, but they were present, and you could always find them in multiple locations around the Bay if you went looking for them, generally in small numbers. And so I began looking into this issue and what the evidence was for this disappearance and reappearance. And after some questions and so on, it turns out that this was the source. An article that appeared in the San Francisco Chronicle almost exactly 10 years ago. This was the top story, headline story, covered 2/3 of the front page, above the whole story, about the native oyster returning to San Francisco Bay 130 years after vanishing. And it is a fascinating story that I told here. These are about some fishery consultants who'd been hired by a real estate investment firm that owned some tidelands in the South Bay and was finding it impossible to build on them because of all the annoying environmental regulations that controlled shoreline development. And so they decided maybe they'd try doing some aquaculture on these lands. And they hired these consultants to figure out what they could do. And the consultants thought, gee, you know, this is a real opportunity. Maybe we can use this project to help bring back the native oyster. I wonder if there are any still out there. And so they decided to go looking for it. They talked to a sailing instructor in the South Bay who knew the lands down there, asked them to look for them. And one day the sailing instructor comes in. One day they're doing some marsh restoration out there with heavy equipment. One day the sailing instructor comes to them with a shell that a gull dropped near his house. And he shows it to them, and sure enough, it looks just like the native oyster. And they compare it to this 19th century text, a description of the oyster, and it conforms in every detail. And they collect some of these, and they're going to breed these in order to develop a breeding stock to bring the oyster back to the Bay. They're going to get the DNA checks to make sure it's the right thing. And they tell the reporter, they tell them, we're keeping the location secret, they say. If they leaked out, the oysters could be exterminated in nothing flat. Really a sort of gripping and fascinating story about the return of this native organism to San Francisco Bay, and the only problem being that it is complete and utter nonsense. This was part of the work we'd done in the early 1990s. I ran a number of surveys looking for exotic species in the Bay, throughout the Bay. And in 1993 to 1997, we visited a bunch of sites within the main, what's thought to be the main potential range of the native oyster from the South Bay up through San Pablo Bay. And in every year, we found the native oyster in more than half the sites. And in every year, it was common in at least 1 or 2 sites. Well, that was the 90s. Maybe it had come back in the early 90s, and we hadn't realized that it was a novel thing. And then these guys found it in the late 90s. But then I looked back at a compilation of benthic research that had been done. And in every year in which we had studies, there were records of oysters out there in the Bay. In the 70s, we started to have a lot of studies, but very few in the 50s and 60s, really the first one in 1951. And every year it was found in at least 1 location, usually in multiple locations, in which people had gone out and sampled the Bay. There's remarkably, before 1951, there was only 1 prior benthic survey of San Francisco Bay, and that was in 1912 when the fisheries steamer Albatross visited the Bay for an extended period, an extended study. And in that case, they took dredge hauls. I don't know if you can see the markings on the map, but a large series of dredge hauls throughout the Bay, mostly in the deeper waters, and they collected native oysters at 17 sites in that study. And so this data overall seems to indicate pretty similar levels of oysters throughout all the years at which we've been out sampling them, 1911, 1912, the studies from the 50s to the 70s, our own studies in the 90s, and our own experience up to the, nearly up to the present, which is that the oyster is out there. It's not abundant. Occasionally it's common in some areas, but it's also not rare. It can be found. And so the upshot of all this is that the common understanding of the oyster history shared by people who were working on oyster restoration in the bay, as well as apparently many other folks, the last part of it at least was not true. And that led me to think about the earlier parts. There were some of the aspects about the explanation of decline, over-harvesting, pollution, mining sediment, which hadn't sat that well with me. And so I began looking into whether, in fact, these are likely sources of decline, starting with some sense of the history of the region. The bay first discovered when Portola got lost and wandered up the peninsula and saw the bay in 1769. The first expeditions to the bay, Ayala on the vessel San Carlos coming in to survey the bay, Anza and Pedro Font coming in to pick the sites for the Presidio and the missions. Mexican independence in 1934, gold discovered in 1848, big population boom. And in 1850, we start importing the very same species of oyster, the Olympia oyster, from Willapa Bay in Washington, and growing it up, holding and growing them in San Francisco Bay for the San Francisco Bay market. Well, that's kind of interesting. And then in 1869, 20 years later, as soon as the Transcontinental Railroad is completed, we start bringing in oysters from the East Coast, much bigger oysters, and growing them in the bay as well. And so from the 1850s on, oysters in the bay were largely supplied out of aquaculture operations, of these rearing operations in the bay. But it's really kind of interesting that we started it as early as 1850. Had we, by 1850, so decimated the native oyster population that we had to start bringing in the very same species of oyster from further north? Could that be the case? This is the city of San Francisco in 1849. And it probably held more than half of the residents of the entire seven-county Bay Area. This does not look to me like a population which could have over-harvested a massive shellfish resource in San Francisco Bay. It doesn't look to me like a community that could have so polluted the entire bay that a massively abundant shellfish would have disappeared. If we take a look at population data that we have, later data from the census, earlier data from various counts and published reports, we see that the numbers are very low up into 1849, and then with the gold rush, they start to rise. The total Bay Area population over this time, nine-county Bay Area, was probably double or less these numbers. This is San Francisco population alone. So you can get a sense of the entire population of the area. What's interesting is you think about our current estimates of the native population of this area at the time of European contact. Older estimates were about 7,000 Native Americans living in the bay and around the bay itself. More recent estimates seem to be in the area of 20 to 25,000 Native Americans at the time of European contact. That native population was rapidly either died or moved to other areas to get away from the arriving missionaries and soldiers of the Spanish realm, and the populations of native populations plummeted. And so it's very likely that when you look at these numbers, double them to get the Bay Area population, add in the remnants of the native population that weren't in the missions, because these numbers include the mission industries, the mission Indians, the ones that were shown here, that the population during this time was actually less than the native population at the time of contact, all the way up to 1849 or so. And so it's very hard to see this as population as destroying a major resource in the bay that had been there for a long time, as we understood it. As far as hydraulic mining sediment, hydraulic mining didn't start till 1864, so it's not even in the running for getting rid of the oyster by the time we started bringing in the Willapa Bay oysters. So that remains a puzzle about why we might have been bringing them in. But I guess the question we want to think about and look again at these populations, well, if we didn't kill off the population of oysters by 1850, could we have done it over the next 50 years? Could we have done it over the last half of the And what evidence do we have that that happened? And so here I turn to the main writings that we have on the history of the oyster in San Francisco Bay and in California. And there's not that much. Ernest Ingersoll did a report on the oyster industry for the US Census in 1881. He did it from the East Coast. He never came out here. He corresponded with some folks out here. He interviewed a guy who shipped eastern oysters out to the West Coast, and he read some of the San Francisco newspapers in the late 1870s and cited some information from them. And so that was his report, not much in it. Townsend did spend time out here. He was busy doing other things, had other responsibilities, but he spent some time in the oyster beds. Mainly his interest was to figure out whether the eastern oyster, which we've been importing since 1869, whether it was reproducing here. But he also put together some information on the native oysters being cultured, that is the Willapa Bay oysters being cultured, and some statements in there about the native fishery. Bonneau, mostly concerned about the Japanese oyster at that point, a little bit about the native oyster in his study. Skinner's mostly a rehash of things that had gone before as far as oysters. Barrett had some new information. Eleanor Barrett did a master's thesis here at UC Berkeley and on the California oyster industry. It was published as a bulletin by the Department of Fish and Game. And one of her main contributions was she did a pretty thorough look at the newspapers of the 1800s. It had cites and quotations from 8 different San Francisco newspapers that published between 1848 and 1898 from stories about the oystering industry, the aquaculture oyster itself. And so that was a major addition. Since that time, anything that's been written on the oyster in California basically quotes these works and has brought nothing new to it. So what did these people have to say about the decline of the native oysters and about the causes of the declines of the native oysters? Well, Ingersoll did address the question of harvesting of the native oyster. He said, in the early days of settlement, the native oyster was harvested, but it was considered to be of small consequence. That's what we know about them. None of the others even mention harvesting of the native oyster. Not that it was big enough, not harvest enough to decimate it. They don't even mention that it was done. Pollution issues are not mentioned by any of them as impacting or having any effect on the native oyster. There is discussion of pollution affecting the eastern oysters in around the turn of the century, around 1900, 1910, but nothing about impacts on the native oyster. They do talk about sediment coming down from the Sierra Nevada, and especially in the Great Flood of 1862, and killing off cultivated oyster beds in the northern part of the bay, and convincing the growers to move their oysters to the southern part of San Francisco Bay. But no actual suggestion or hint that these things might have killed off the native oyster population in the bay. In fact, they don't even discuss the native oyster population in the bay for the most part. So where do these ideas come from? I spent a lot of time looking at what I could find, and other than Ingersoll's statement that the native oyster was harvested but of small consequence, or in the early days, their first reference to harvest decimating the native oysters or reducing the native oysters that I could find was in a story in 1996, which has no reference and has no indication of where that information comes from. It is just stated. With regard to pollution, there were some geology papers in the 1960s which suggested that pollution since World War II had been killing off the native oyster. But that's a little late for us to see the loss of the major shellfish beds of native oysters in the bay. And it doesn't appear that they had any evidence that that was happening. They just didn't find any native oysters now, so they assumed that it was the pollution in the preceding years that had killed them off. There's a vague reference in 1979 in Fred Nichols' paper, which probably refers to impacts on cultured oysters around the turn of the century, but it's vaguely worded. Maybe it refers to native oysters. And the first clear statement appears in the newspapers in 2001. The first actual statement to clearly make a connection between pollution and the demise of the native oyster in San Francisco Bay. And so we have very little to go on. The story with hydraulic mining being a potential impact slide dealing with this. Yes. A lot of sediment came down from hydraulic mining in the Sierra Nevada. And a good deal of sediment was deposited in this one set of studies of sediment rates in the upper part of the bay in Carquinez Strait, and then it moved from Carquinez Strait into San Pablo Bay. As the years went on, this mass of sediment on the bottom moved into the Central Bay and out the Golden Gate, but it never got into the South Bay. In the years here, the South Bay was actually eroding a little bit, not sedimenting, and over the years, virtually no of the hydraulic mining debris ever got in there. And so while conceivably hydraulic mining might have had an impact on oysters in the northern part of the bay, it couldn't have had an impact on oysters in the southern part because it never got there. And so we're left with no mechanism. If it wasn't overharvesting, and it wasn't pollution, and it wasn't sediment from hydraulic mining debris that killed off the native oysters, what could possibly have done it? Good idea. Good idea. There's one thing that I could think of, and that would not so much a competitor, but an oyster disease. Maybe when we moved in those other oysters, they brought in something with them, especially the eastern oyster, a different species perhaps. And so maybe in 1869, an oyster disease came in, which did away with the native oysters. We have no records. It would be good to know if this was the cause, and we're doing restoration because it's something we would have to deal with. But we have no evidence that it is, but that's one possibility. It's really all I could think of. And then, inevitably, one other possibility came to my mind. What if we never had abundant native oysters in San Francisco Bay? What is the evidence that they were ever abundant? Well, there are a couple different kinds of evidence we could have. We could have actual written accounts describing beds of oysters in San Francisco Bay. Intertidal beds, more likely, would be described because we would be able to see them, possibly subtidal beds. These might be in the scientific literature. They might be in the popular literature. As far as we can tell, as far as all those researchers can tell, no such descriptions exist. We have no written record of the existence of these beds in San Francisco Bay. We might not, they might be there, but we might not have them. This was at an early time if they died off early enough. Another source of information that we would expect to find, I think, is records of harvesting them at a large rate. If they were there, especially before we were bringing in the Willapa Bay oyster, we'd be harvesting them as colonists. They'd be a source of food. There would be some record of people doing that. There certainly are records up in the Pacific Northwest of harvests of this same species in the bays where we know they were abundant and they were harvested. But we have no contemporary records at all of people harvesting oysters out of San Francisco Bay in the 1840s, the 1850s, any time at all, really. And it's worthwhile thinking what we do have records of. We have records, I have found records in newspapers or in journal reports of the harvesting of clams in San Francisco Bay back around the 1850s, of the harvesting of mussels in San Francisco Bay by settlers back at that time, the harvesting of crabs, the harvesting of octopus in San Francisco Bay. But I have not found a single mention of a single individual harvesting an oyster out of San Francisco Bay in any of the records. They may exist, but we would expect them to be easy to find if this was an abundant resource available in the Bay Area. There are two other sources of information that people turn to. One of them is the shell mounds. There are 425 shell mounds that have been located around San Francisco Bay, none in existence anymore, most of them. The remnants of some may be buried in some places. Only a small number of them were excavated carefully. But these shell mounds surely are evidence, full of oysters. Massive harvest by the Native Americans right up to the time of European contact. This must show large numbers of oysters in the bay. As it turns out, the data on the shell mounds is this, that most of them didn't have oysters in them. They were primarily clams and mussels throughout most of the bay. There were 5 shell mounds in the East Bay and 2 shell mounds in San Mateo that had a good deal of oysters in them. The 3 largest shell mounds, the Emeryville shell mound, the West Berkeley shell mound, which is shown here in 1950, when the last excavation on it was done before it was destroyed, and the Ellis Landing shell mound up in Richmond. There were excavations done on them which identified shells to type and sorted them by layers. And what those excavations show is that from the bottom layers of the shell mound, there are abundant oysters and abundant mussels in the shell mound. But you get up to a certain point, about 6 feet below the surface in 2 of the shell mounds and about 15 feet below the surface in the other, and the oysters disappear. And the upper part of the shell mound has mussels and clams, and very few or no oysters. Apparently, at some point, the Native Americans stopped eating oysters, presumably because the oysters were no longer there. Lynn Ingram dated the transition point in one of these shell mounds, in this West Berkeley shell mound, and found that it dated at 2,000 years ago by radiocarbon dating of charcoal and shells. The other piece of evidence that people point to is the deposits of oysters around the bay. There are large lenses and extensive lenses of oysters that sit under the mud in parts of the South Bay. And there are berms that have been built up. This is that picture from the San Francisco Chronicle. Berms that have been built up along beaches and so on of dead shells that are apparently from these deposits. These folks are standing on one of these berms in the South Bay. And there are lenses of shells that are exposed in parts of the North Bay above the water at Rodeo, Benicia, Mare Island. And so these are evidence that the oyster did flourish in the bay at some time. The exposures in the North Bay have been dated as being the last interglacial period. So they're like 80 to 125,000 years ago. They don't really help us with understanding what we can do today. The other oysters, though, the deposits in the bay, there's a large deposit. I don't know if you can see this one. It's about, this is the oyster shell deposit up here. There's a smaller one down at a greater depth. This is the mud surface, the ship channel. And so this oyster, extensive lens, this is revealed by boreholes down around San Mateo Bridge in this work by Story et al. It sits between 2 feet and 8 feet below the mud surface in the place where they examined it. And it's 8 to 15 feet thick of shells, essentially all oysters. And they dated this with radiocarbon dating, and they found the top edge of this, this lens to be 2,300 or 2,400 years old. Now, there are some things about dating shells. These were dates on shells, in which the dates have to be corrected relative to carbon radiocarbon dates done on carbon material and on wood material or charcoal material. And that involves a reduction in the year. I don't really know how to apply it to this. It's a little bit outside my field. But it may be that that would reduce these numbers closer to about 2,000 years old, which is the date in the shell mounds. Or maybe it wouldn't. I need to get in touch with someone who is more familiar and knows whether a correction should be applied to this 1966 paper. And then, I don't have a slide for this, but Lynn Ingram did another bit of radiocarbon dating work on some boreholes near Oyster Point, and she found in the sediment a transition point between oysters and clams, the same clam, Macoma nasuta, that was in the shell mounds, and that also dated at 2,000 years ago. So there's evidence both from the shell deposits and from the shell mounds, generally consistent, that the oysters disappeared about 2,000 years ago in San Francisco Bay, but were very abundant before that. So our story of the history of oysters in San Francisco Bay, broadly accepted by most people, I think. Certainly the early part about the abundance and decline, and the later part by many people had sort of worked its way into our understanding of the bay. But that doesn't seem to be true. So what is it that we do have at this point that we know about the bay and oysters in it, and what can we say about it? Well, as far as we know, they were never abundant. This doesn't prove that they weren't. There's more information to be looked at. There's more data to be researched. There's more historic records. Maybe there is information about harvesting them in the bay in the past. Maybe there is more that can be learned from the shell mound literature. I have not reviewed all of it. Maybe there is some shell mounds that have oysters, show evidence of harvesting large numbers of oysters up to the time of European contact. And that would change this picture. But at the moment, as far as we know, there is no evidence that oysters were ever very abundant in the bay. And there's a lot that suggests the absence of all types of evidence that we would think we would find suggests that they probably weren't. What that means for oyster restoration is it's a lot dicier proposition. If for 2,000 years the bay hasn't been a suitable habitat for large numbers of oysters, it's a much more ambitious task to try and create oyster beds where they haven't been for 2,000 years. It's not going to be a small manipulation. It's going to be a matter of fundamentally changing the bay environment so it's now a suitable environment for large numbers of oysters. And even if that were something that we could do, it's very doubtful that we would want to. Which puts the entire process of oyster restoration into a very different light. If they were abundant, we have no idea why they disappeared, which makes restoring them hard as well. And so, what's that?
What happened to the introduction?
The eastern oyster never reproduced well in the bay, although it did reproduce sometimes, and the Japanese oyster never reproduced well in the bay. And so they were grown for a time, and then they were gone. It turns out we currently have an invasion of the Japanese oyster in San Francisco Bay. We don't quite know why. We have some thoughts about it, but they were found, first one was found in 2004, and we're busy trying to get rid of them, actually, and think we are likely to be able to. And actually, part of the reason people wanted us to get rid of them was because there are these native oyster restoration efforts going underway, and we didn't want the exotic oyster to interfere with them. All very interesting. So I'm going to try and run through this last bit quick. I'm going to try and show you a few pretty pictures and hopefully leave you with a pretty thought. In 1776, when Pedro Font arrived in San Francisco, looked down from Fort Point, he saw below him sea otters splashing in the waves. Sea otters were very abundant at that time. During the Spanish occupation in the early 1800s, American and Russian ships came to San Francisco, to the area of San Francisco, to hunt for sea otters because their pelts were very valuable. The American ships, often crewed by Hawaiian natives, carried hunters from the Aleutian Islands who hunted in basically large kayaks in San Francisco Bay. At times, we know from records that there were as many as 100 kayaks on San Francisco Bay chasing sea otter, a really astonishing thing to think. And the records show that they collected, in some weeks, hundreds of pelts in a single week. And then they go away for a few years, and they come back and they do it over again. And then they go away for some years, and they come back and they do it over again. And this went on, and the oysters and the sea otter declined. And the last sea otter that was known of at San Francisco Bay was shot in 1846. Since the 1970s, there have been occasional reports of sea otters in the waters around San Francisco Bay and occasionally even in San Francisco Bay. And it raises the question, could they be brought back to San Francisco Bay? We think of sea otters as inhabitants of rocky outer coast kelp forest environments feeding on abalone, but in fact they are highly adaptable animals. They live in many different kinds of environments. They eat a wide variety of foods. In Elkhorn Slough, a muddy slough, they feed on the exotic eastern clam, Maya arenaria, the soft-shell clam, which is also abundant in San Francisco Bay. In Alaska, they feed, a lot of their feeding is on fish species, many of them which are also found in San Francisco Bay. In Morro Bay, they go down to the bottom and they pick up beer cans and soda cans that have been tossed in, and they bring them up to the surface and they extricate from them octopuses that have taken up residence inside the cans. And so an animal that can figure that out has some potential to adapt to a new environment, one where it hasn't been for a while. They're very tolerant of civilized surroundings. They are comfortable in many cases around marinas and harbors. Experiments that tried to figure out how to scare them away from oil spills by various kinds of loud noises and air horns found that they adapted to them very quickly. They're actually curious about the works of man. They're curious about buoys and boats, and they seem like an animal which could actually live fairly well in civilization. One aspect of them, which may, however, be a problem in San Francisco Bay, is that they're the only marine mammal that isn't insulated by blubber. They're insulated by air, which is trapped in their hair. Their hair is specially designed for it, but for it to work, their hair has to be very, very clean, and they spend a lot of time grooming it. And so one possible problem would be something like hydrocarbons on the surface of the water, oil and gas from boats and so on. This could be a problem for sea otters. Certainly major oil spills are a big problem for them. And the other aspect of this is that any contaminant gets on their fur because they do so much grooming, they end up ingesting it, potentially also a toxic problem. The flip side of thinking about that possible threat to the sea otters was that if there were sea otters in San Francisco Bay, there would be a much greater impetus to try and clean up those remaining pollution problems in the bay, and much more public support for it. So, interesting kind of combination there. Another aspect of the fact that they are blubberless is that they have to eat a lot in order to stay warm. And they eat things like abalone and shellfish, and herein lies a serious potential issue and problem with moving them into the bay. Their feeding on abalone has certainly been a problem for efforts to establish populations elsewhere and to protect the populations that exist. And in San Francisco Bay, an issue we might be concerned about is their potential for feeding on young Dungeness crab that come into the bay from the Gulf of Farallones to grow up to in their first year of life and before moving back out there. And so there are definitely some sticky issues that might arise if we begin a conversation about whether or not to restore sea otters to San Francisco Bay. Among other things, I think the good folks who take our wastewater and treat it and release it out of the bay cleaner than they got it, but not perfectly clean, would not be at all happy about conversations about bringing sea otters into San Francisco Bay. But those are issues we would have to deal with. I had meant to show you a couple more pre-pictures, but I've gotten ahead of myself. And so, I guess I just wanted to say that those kinds of issues, there are a lot of appealing things about thinking about bringing these creatures back to the bay. We know they were abundant. We know they were important in the ecosystem. They're a keystone predator. We know why they're gone. It's because we hunted them out. We know what we have to do to restore them. It's to bring some breeding pairs back and then try and figure out what conditions we need to create in order to keep them healthy. Research that as best as possible, but eventually we would just have to try it. It's all pretty clear, but there are these very serious issues about how those organisms brought into the bays, those critical organisms in the system, may change the bay. And so I am not at all sure that we ought to restore sea otters to the bay, but I am sure that we should have a serious conversation about it in the community here. The big problem in the bay, the real threat to the bay, it's not a lack of acres of salt marsh. The bay is not ultimately suffering most from not having beds of oysters, and it is not suffering from not having sea otters. The biggest threat to the bay, the biggest lack, is the lack of attention from most of the 7 million people who live in the counties around it. And there is nothing that I can think of that would get their attention and get them to care about the bay more than the potential for restoring sea otters into the bay, even just having a discussion about it. And so for that reason, despite the many difficult issues, I believe we should give this possibility some real serious consideration. Thank you very much.